It'll be directed towards the sun. In other words, this is 1% of the Earth to sun distance. The sun, of course, is a giant gas sphere. Aditya-L1 will study its outer atmosphere. So that's what the broad goal is. But before we talk about what India's Space Observatory Aditya will do in space, we need to talk about how it will get there. And that is through the PSLV rocket on which it is mounted. Now, the rocket being used, and you can see it there, the PSLV-XV. PSLV stands for Polar Satellite Launch Vehicle. This is the 59th flight of the PSLV and the 25th flight of this variant. The rocket is 44.4 meters high. In other words, as tall as a 13-story building. The PSLV-XV has a launch weight of 321 tons. So what are the sensors on board Aditya to help it study the moon? This is in fact what the Aditya mission is all about. What you see on your screen is the visible emission line coronagraph. It functions as a reactive coronagraph for imaging of the corona and spectroscopy. There's also the solar low energy X-ray spectrometer. It helps in the study of solar flares by measuring soft solar X-rays. Again, we'll explain all of this to you over the next 1 hour. There's the plasma analyzer package. It's designed to understand solar winds and its composition. Also the mass analysis of solar wind ions. There's the high energy L1 orbiting X-ray spectrometer. What does that do? It's designed to study solar flares in high energy X-rays. There's the solar ultraviolet imaging telescope. The images that the solar disk in the near ultraviolet wavelength range provide through this device will be useful for scientists. There's also the Aditya Solar Wind Particle Experiment. This has 2 sets of sensors, 4 in total. You can see that on your screen. These are designed to measure the protein as well. There's a magnetometer, which measures the low intensity planetary magnetic field in space. It's a part of a 6-meter-long boom that Aditya will eventually deploy once it gets to its position. So those are the instruments on board. It sounds very high-tech. We'll explain it to you, but quite clearly, and this is a common misperception, Aditya is not headed anywhere close to the sun. It would burn out if that were to happen. What it is doing is heading 1.5 million kilometers from the Earth to deploy to a spot in space called the Lagrange point. What is the significance of this? Here are some details. Initially, the spacecraft will be placed in a low Earth orbit. The orbit will be made elliptical and the spacecraft will be launched towards what I just mentioned, the Lagrange point. That's marked L1 in the middle of that screen. The spacecraft will exit the Earth's gravitational sphere of influence. Aditya will be injected into a large halo around L1 or the Lagrange point, as we point out over there. The total travel time to actually get here will be 4 months. So that's important.
Magnificent liftoff of PSLV-C57 with Aditya-L1 on board.
Plus 15 seconds.
PSLV-C57 का सफल उत्थापन और इसके साथ प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने। इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV-C57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground-lit and air-lit strap-ons, operating together with the first stage, S139.
Ground-lit strap-on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप-ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।